Hey folks, we're going to talk about some logarithms today, one of the most challenging topics for any Algebra 2 student, and one that I have kind of a sore spot for because I find that teachers tend not to teach it in a very effective manner. Uh, I'm going to talk today with this practice sheet here, which is talking about rewriting equations that are as a logarithm in exponential form. And so if you get the teacher version usually goes something like this. Oh, well, it's just 6 to the third equals 216 because you take this number and you put it here, and then you take this number and you put it here, and then you take this number and you bring it over here, and hocus pocus, there you go, problem solved. And that makes absolutely no sense because how do you know which number goes where? How do you keep track of this stuff? It's completely preposterous. Maybe you can remember that the 6 is the base of the logarithm, it's the base of the exponent, but keeping the other two numbers straight, that's incredibly difficult. In this case, it's pretty obvious that 6 to the 216th is not equal to 3, but most of the time, these problems are ridiculous if you follow the shell game method of just shoving things around and seeing where they go. So, what I want to do is actually drop back for a second and talk about how to legit do exponents and logs. So, the important thing to remember, first of all, is that a logarithm is the inverse to an exponential. And that is the reason they exist. They were literally created to be the thing that undoes an exponential function. And if you remember it in those terms, it's not so bad. So if I say 3 to the x is equal to 81, yeah, we can write this as 3 to the fourth and solve it. We know how to do it, so we know the answer is going to be 4. But let's talk about what we really need here. In order to solve this equation, if this was any number we didn't know, any number between 27 and 81, for instance, um, we would need to figure out how to get this x downstairs. We have 3 to the x, and we need to undo the 3 to the. So what do? We use a process that will reverse it, which is called a logarithm. So we write log of on both sides. Now this is like an f of x sort of thing. It does not mean log times. Don't say log times 3 of x. This is like f of 3 to the x, right? You wouldn't say f times 3 to the x. So log of 3 to the x, and specifically because this is a base 3 exponent, we need to say that this is a base 3 logarithm. Now, if we've done our selection correctly, log base 3 of 3 to the, these are just going to cancel out. And we're left with just x. And on the right, well, that's what calculators are for. You cannot do a logarithm by hand unless it magically works out to one of these types of situations like 3 to the x is 3 to the fourth. So this specific question, yeah, we could have done it without a logarithm, but we wouldn't have used a logarithm. We would have made the basis the same as the exponential. So if you're going to actually compute a logarithm, you are going to need to use a calculator. So we would go to our calculator and we would say log base, put a 3 in the bottom square and 81 in the top square. Or if you don't have that feature on your calculator, then you're going to type log of 81 divided by log of 3. Or if it's a scientific calculator, you'll have to figure out specifically how to make that happen. But this is using something called the change of base rule, which you'll probably learn later in the chapter. Anyway, the answer to this is 4. Now that's how we create a logarithm solution to an exponential problem. But what if it's the other way around? What if we have log base 5 of x equals 2? Well, we just got done saying that a logarithm is the inverse to an exponential. Inverses work in both directions, though. So that means that an exponential is the inverse to a logarithm. So we're going to use that idea. And we're going to say, well, what if we had uh, log, or we'll use the one we got that I already wrote, actually. How about that? So log base 5 of x equals 2. Let's just take this right here. I'll bring it down. So what do we do with this? Well, we have to apply a process to both sides. So I'm going to rewrite this in a specific way so that this looks better. So what we're going to do is we're going to say, well, the base of our logarithm is a 5. So if we're going to use an exponential to solve this, the base of the exponential should also be a 5. We're going to do 5 to the on both sides. So if we do 5 to the on both sides, the 5 to the log base 5 part will cancel. And we will just be left with x is equal to 5 to the second power. And we can do that one without a calculator. That's 25. So that is how we approach this. However, if we wanted in quote exponential form, we would have just left it as x equals 5 squared, which is what these worksheets are calling for us to do. So this is the general process. We are doing something to both sides, and then we have to remember that no matter what, log base whatever, log base b of b to the stuff is equal to stuff. And b to the log base b of stuff is also equal to stuff. So screenshot that, set it off to the side. Remember this because this is the whole idea. Do something to both sides. Please, please, please do not do the shell method version, shell game method, where we're just hocus pocusing things into different places. You'll never remember anything. You'll never understand why this is what it is. You'll never get the point of what you're doing. It'll be the most ridiculous, inane topic in the world, and that is going to be the experience of like all your classmates, unless your teacher is explaining it as do this process to both sides, because that's how it works. So with that said, let's get back to our worksheet now. So I gave you the hocus pocus method before, but now let's do this the correct way, which is to say, let's do 6 to the on both sides. The 6 to the log base 6 cancels out, and we have 216 equals 6 to the third. Boom, done. That's all you have to do. One step, nice and easy, and it actually makes sense. Unlike the shifting things around and just put things in the correct places version. So log base 12 of 144. All right, so it's base 12. Let's do base 12 to both sides. 12 to the log 12 cancels out. We have 144 equals 12 squared. Base 7, do 7 to the both sides. Cancel. Well, cancel. Y equals 7 to the x. 361 is the base. Sure, why not? 361 to both sides. Cancel. 19 is equal to 361 to the 1/2, aka square root. 144 to the on both sides. Cancel. 1/12 is equal to 144 to the negative 1/2. And you can just keep going through all of these like that. There's nothing more to it if all you're doing is converting. If we scroll down, we'll see that now it's rewrite in logarithmic form. Okay, so this is going in the other direction. We have an exponential. We have to apply a log to both sides. So we take our 9 squared equals 81. We have to do log on both sides. You can choose whether or not you actually write these parentheses. But our base of our exponential was a 9, so we're going to do log base 9 on both sides. And now log 9 of 9 to the is going to cancel, and we just bring down the exponent as 2 equals log base 9 of 81. I'll do one with numbers again. So base 3 here, we're going to do log base 3 of the 3 to the y is equal to log base 3 of x. Log base 3 of 3 to the cancels. We just have y equals log base 3 of x. The rest of these have variables in them, but that's okay. I mean, we can do that. So the base of our exponential is n. So log base n of n to the m is equal to log base n of 1/15th. And then we will cancel. M equals log base n of 1/15th. And you can basically monkey see, monkey do your way through the rest of this. Log base x of x to the y is log base x of 120. Cancel. Y is equal to log base x of 120. And this is how it goes for all these questions. You're just going to apply this process. So a reminder, if you're going log to exponent, step 1 is to determine the base of the log. Do base to the on both sides, whatever that base number happens to be. Cancel the exponential with the logarithm, leaving only the guts of the logarithm behind. That's log to exponential. If we're going to do exponential to log, we're going to determine the base of the exponential. We're going to do log base, whatever the base is, of both sides. We're going to cancel the log with the exponential. Exponential, there I can spell, leaving only the power behind. And then if you have to, you simplify further. With the exponent to log version, you might need to write it on 2 lines. Gasp, oh no. But really, you're only doing one step, one real step, and then you're simplifying it. So there's, at most, you're dealing with the original line. Whoops. You're dealing with a rewrite with the word log on both sides, then you're doing the final version. And there's your whole story. That will solve basically all of these. So is there anything else going on? Evaluate each expression. Okay, so this is a tiny pinch different, but not much. We don't know what the answer to this is, so let's just call it x. Oh, well, we know how to rewrite these, don't we? Let's rewrite this in exponential form. So we'll do 6 to the on both sides and cancel, and we get 216 equals 6 to the x. Well, 216 is 6 to the third equals 6 to the x, and that means that x equals 3. Of course, you could do these, just type them into the calculator, which is a much simpler way to approach it. But if you have to solve them without a calculator, just set them equal to x. So log base 8 of 64 equals x. 8 to the on both sides, cancel. 64 equals 8 to the x. 64 is 8 to the second power. So that means that 2 equals x. Log base 2 of 1/16 equals x. 2 to the. We get 1/16 equals 2 to the x. 1/16 is 1 over 2 to the fourth. So in other words, 2 to the x equals 2 to the negative fourth, and therefore x equals -4. 26, well, we basically just did 26, except it's not 1 over, so it won't be negative. That's just going to be x equals 4. But all these ones that are like a fraction, yeah, they're just going to have a negative number. And again, as I said, you could just type this into the calculator, but usually this is the kind of question where Teacher's going to be like, oh, do it without a calculator. Um, and this is the very rare case where it's rigged to work this way. Normally, you would not be able to do this. Normally, you do not solve an expression that is nice and neat and written to plug into the calculator by going, oh, well, let me make it more complicated. But in making it more complicated, we have actually written it in such a way that we can solve it by hand. So there you go. Presto changeo, there's the idea. I'm going to do the one more. I'm going to do 31 because I want to point out the specifics of this one. And that is if we do 3 to the on both sides, we get 1 equals 3 to the x. And you go 3 to the x equals 1. Well, you don't even have to go to an exponential expression to know the answer to that one. Any number to the 0 power is equal to 1. So one last tidbit I'm going to leave you with when it comes to talking about this sheet, and that is log base b of b is 1. If you do log base 3 of 3, it's 1. If you do log base pi of pi, it's 1. If you have log base b of b to some power, it's just equal to that power. And there are a variety of reasons why we can argue that, but the easiest is just that these cancel and bring the power down. And finally, log base b of 1 will always be equal to 0 for the very reason that we described over here, that you're basically saying b to the what power is equal to 1, and therefore you will always get an answer of 0. So that is the rundown on this crazy worksheet. Now, I do have one other worksheet here to take a look at. Um, and it looks like it's more of the same. So we're just going to do more of the same stuff. So for instance, log base 2 of 128 equals 7. We will do 2 to the on both sides. And we will cancel, and we'll get 128 equals 2 to the 7th. Boom, done. Write it in logarithmic form. All right, well, we have to do log base on both sides. The base of the logarithm of the exponential, excuse me, is a 4. So it means the base of our logarithm has to be a 4. And now log 4 of 4 to the cancels. The 4 that is a power comes down, only that 4. I realize there's a lot of 4s in this question, but it's specifically the 4 up top that we're preserving. And there we go. And now, evaluate each logarithm. Use change of base when necessary. Oh, so that means if we can use change of base, that means we're allowed to use calculator, I think. Okay, so this is the same thing if you're going to use the quote change of base rule as log base whatever you want of 36 over log of 6. And that's if you're going to use the change of base rule. Again, TI-84s and other more current graphing calculators have a thing in their math menu just as log base. You wouldn't even have to do this. So if you're doing it with a calculator, hey, there you go. There's your method. But if we have to do it the long way, equals x. Do 6 to the on both sides. Cancel. 36 equals 6 to the x. 36 is 6 squared, so 6 squared equals 6 to the x. And therefore, 2 equals x. And that's how you would solve it by hand. It's just like the bottom part of the last worksheet. So more of the same, different worksheet, but SSDD. So this should keep you going, and hopefully now you will recognize how to go back and forth between exponential and logarithmic form.